all you Gretas and Shutascats out there. Welcome to Chapter 5, Section 2, How do Ecosystems Respond to Changing Conditions? So this is succession, both primary and secondary, and these are things that you learned about freshman year, so this should be a fairly, hopefully, an easy review for you guys. So ecological succession is the normal, gradual change in a species composition in a given geographical area. So you have steps of development. You're never going to go from an abandoned field to a fully developed forest overnight. You have to have a process, which is called succession. So this is the species composition of an ecosystem or a community can change in response to changing environmental conditions. So sometimes something happens, a fire, volcano, climate change, clear cutting, and the ecosystem is destroyed in some way. It's going to come back in this process. So we have both primary and secondary succession are examples of natural ecological restoration. So we're going to start with primary ecological succession, the gradual establishment of biotic communities in lifeless areas where there's no soil in a terrestrial ecosystem or no bottom sediment in an aquatic system. Ugh, that's like a lot of words. So life is not in an area. Then life comes to an area. That is primary succession. So if you start on bare rock, if you start on like the side of a volcano, that is primary succession. Primary first. This is the first time life comes to an area. This can take hundreds to thousands of years, depending on where you go. But if you're starting with bare rock, it's really hard. If I handed you a rock and a seed and said, plant a tree, kind of hard to do so. It takes time because you have to do that soil thing. So first you have exposed rocks. Then over time, you have mosses and lichens that come in. These are very simple plants that don't really need soil. So they dig into the sides of the rocks and they break down little bits of the rock, and then they themselves live and they die. And then you have very shallow soil, because that's what soil is. It's little pieces of rock and dead plants and a little poop thrown in. So all of that dies, and then you have your shallow soil. So you get small herbs, small shrubs, and then you get bigger things and some basic trees, some simpler trees, and then you'll eventually get your fully formed climax community. So this can take, to go from bare rock to that full forest, can easily take hundreds, if not thousands of years. Secondary succession. Here's the easy way. Secondary succession starts with soil. You had your climax community, you had your fully established forest, but something happened and it went away and now it's coming back. So this occurs where communities or ecosystems have been disturbed, removed, or destroyed, but retain some soil or bottom sediments. Once again, secondary succession starts with soil. Primary, first time life has come to an area. Secondary starts with soil. If you have soil of any kind, you're talking about secondary succession. This is a big, important ecosystem service. It's going to help enrich the biodiversity of communities and ecosystems by both increasing species diversity and interaction among species. It doesn't always follow a predictable path, but we usually have an idea of how it's going to go. It also enhances sustainability. It promotes population control because it can help increase the complexity of food webs. It enhances energy flow, increases nutrient cycling through as these steps are being achieved. So very similar to the other one, but we don't have to start with rock. We get to start with soil because secondary succession starts with soil. So it's much easier for maybe roots were already there under the ground and they're just going to grow the plants back up, or seeds dropping in on the soil have established soil, so they'll grow much faster. So you have your weeds, your annual weeds, and then your perennial weeds and grasses, and then your shrubs and small things, and then your larger ones. And once again, you'll get to your established climax community. This takes much less time. You can easily do this in 100 years-ish. 150 years. So living systems are sustained through constant change. So things rarely stay the same way forever. They're going to change. They arise out of a complex process that results in some degree of either stability or sustainability. So they'll withstand external stress in response to changing environmental conditions. So there's two ways or two aspects of this. when you're talking about how stable or sustainable an ecosystem is. You can have what's called inertia or persistence. And this is the ability of an ecosystem to survive moderate damage. So this is kind of like how hard can you hit, or how hard can you get hit. So if you're having those moderate disturbances, can you handle those? And then, so think of maybe one tree alone in a yard in a thunderstorm versus a whole forest. The forest is going to be much better at persistence because they've got kind of better support system. And then resilience is the ability of an ecosystem to be restored through secondary succession after a severe disturbance. So if I had a forest fire and I just took the whole forest out, trees are gone, everything is down, or you had a fire in the grassland, they're both decimated, but that grassland is going to be much more resilient and come back much faster than the forest will. So the forest might have better persistence and inertia, but that grassland is going to have better resilience. So hopefully that makes sense to you guys. And you have survived this round of notes. So before I go, I want to let each and every one of you know that you are good enough, you are smart enough, and people do like you. And in case I don't see you, good afternoon, good evening, and good God, do your homework.